Hello students, welcome back to my channel Explore Physics, Let's Explore. Hope you all are doing fine. Today I'm going to start the next chapter for class 10th, that is magnetic effect of electric current. We've already discussed before the different effects of electric current, and I told you that there are three effects of electric current: chemical effect of electric current, heating effect of electric current, and magnetic effect of electric current. Magnetic effect of electric current we are going to take today. Heating effect we have already discussed in the previous chapter. So without further delay, let's start with the new lesson. Now, what is a magnet? You know that any object which attracts the other objects made up of steel, iron, nickel and cobalt. This is a magnet. You all have played when you were smaller, you had played with the bar magnet, different shapes of magnets. Can we make the magnets, or do we have only permanent magnets? From where it has come actually? You all know when you were smaller, you will know about the story about the origin of magnet, how it's being found and all. You know about the shepherd story and all. So today we are going to discuss about the difference between the permanent magnet and the temporary magnet. So first, permanent magnet and a temporary magnet. So permanent magnet, as the name suggests itself, the magnetism property is permanent. What all other features are there? It has its fixed strength. The strength of the magnet is fixed. The poles, north and south poles, are fixed. You know that a magnet has two poles, north pole and south pole. So a permanent magnet has fixed north pole and fixed south pole. As I told you, its strength cannot be varied. Whereas in a temporary magnet, we can change the strength of its magnetism by allowing more amount of current or more stronger current in it. So we're talking about the electromagnet. So we can change the strength of the magnet, one. Two, we can also change the polarity of the magnet by changing the direction of current. The north can become south and south can become north. So we can change that also. One thing is, here the magnetism property is permanent, whereas in temporary magnet, the magnetism property is only till the electric current flows in it. As soon as we stop the flow of electric current, it loses its property of magnetism. So this is the main difference between a permanent magnet and a temporary magnet. We can magnetize an object made of steel or iron. If you just take a small iron nail or all pin, the paper pin, and just rub it against a permanent magnet, you'll see that small thin nail or the all pin also acquires the property of magnetism. And closer to the iron filings, the filings will go stick to that small piece. Or you can just try it with the smaller iron objects. That iron pin or the thin pin will also act like a magnet, but it loses its property very soon. So by friction we can magnetize the substance. By electricity we can magnetize the substance. How can it loses its magnetism property? By heating it, by hammering or beating it, it can also lose its property of magnetism. So this is all about the magnets, the temporary magnet and the permanent magnets. Now the uses of magnet: the motor revolving, there is a magnet. Magnet is there, electromagnet is there. You have the AC at home, you have the coolers at home, you have the fan, you have the tape recorder, the TVs, the floppies, cassettes, audio cassettes, or the fridges for that matter, all have the magnets or the electromagnets used in it. So there are varied uses of electromagnets. Now, what are the different terms related to magnet? We are going to discuss that. As I told you, it's not like that from somewhere it is dropped down and we have the magnet. It undergoes the process and then an iron object or piece of iron becomes a magnet, the permanent magnet. So we'll talk about the magnetic field. When you just bring a piece of iron to a magnet, you'll see that it experiences the force of attraction. But there is a point only up to which the force is experienced by the object. If you take it farther or move away a little bit, then it will not be attracted to the magnet, because the magnet also has a region or the area around which the magnetic field is experienced. So that is magnetic field. It is the area around a magnet through which or up to which the magnetism property or force of magnetism is experienced by any other substance. If you take farther away the object from the magnetic field, definitely it will not experience a force. So it has a region around a magnet which is called the magnetic field. What is the direction of magnetic field? Does it have the magnitude as well as the direction? Yes. Magnetic field or the magnetic force also I can refer with this. Magnetic force, as I told you, the force experienced because by an object because of the magnetic field present around a magnet. So this has the magnitude, it's a force, scale, vector quantity. So it has a magnitude as well as the direction. Magnitude as well as the direction, it has both. Now, how do we know that till where the magnetic field is extended or is there? Of course, we can just draw the magnetic field lines by which we know that till where the magnetic field or magnetic force is experienced or magnetic field is there. So the lines which show up to where the region around the bar magnet is called magnetic field lines. Magnetic field lines. What are these? So magnetic field lines are the lines through which the north pole of a magnet inside the magnetic field moves. What are the properties of these field lines? We are going to discuss that now. So I'm going to tell you the properties of magnetic field lines. We have a bar magnet which has north and south pole. You know that all the magnets have two poles. If I'm going to break it or cut it again and again, so the smallest piece possible also will have two poles, north and south. I cannot separate north and south pole even in a smallest piece possible also. So how we are going to draw the magnetic field lines? This will be in practical also. If I'm going to put a compass needle, you know that this is north. So you know that like poles repel each other and like attract each other. So if this is the north pole of the bar magnet, this will be the south pole of the compass. So this will be pointed here. You remove the compass needle, put it like this, and here again this will be the north pole. So the magnetic field lines are drawn like this. Okay. In both the directions, we are going to draw the magnetic field lines like this. So, it is always observed that the magnetic field lines move from north and ends at south pole. So, I can show the magnetic field lines like this. So the magnetic field line starts from north pole and ends at south pole outside the magnet. Inside the magnet, if you just see it like this, inside the magnet it goes from south to north pole. It goes like this and this. Inside the magnet it is from south to north. Here if you see the shape outside where the magnetic field lines are crowded, especially at the poles, the strength of the magnetic field is more. As you go further, these are separated, these are wide apart. Here, comparatively, the magnetic strength, the field strength will be less. First property, that it starts from north and merges at south outside the bar magnet. 2, inside the bar magnet it is from south to north. 3, wherever the lines are crowded, especially near the poles, the strength is more. As the distance between the lines are wide or more, the strength will be less. Two magnetic lines never cross each other. So that is also one why. We are going to discuss it later. And these are close continuous curves. So these all are the properties, very important question for the post children. What is magnetic field lines, or what are magnetic field lines? Write 3 different properties of magnetic field lines. So you should know, I'm again telling you, one starts from north and ends at south outside, or merges at south outside the magnet. Inside the magnet, it's from south to north. Then where the magnetic fields are lines are crowded, the strength of magnetic field is more. Where it is wide apart, the magnetic field will be comparatively less. Inside the magnet, the magnetic field lines, if you see, they are parallel to each other. So inside the magnet, the field is uniform. Just remember, when the parallel lines, field lines are there, it shows or it indicates the uniform magnetic field. Then we said that two magnetic field lines never intersect each other. Then these are the close continuous curves. So these are different properties of magnetic field lines. Now, why can't two magnetic field lines intersect each other? We are going to discuss that. Very important question again. So I hope this is clear to you. Now, why can't two magnetic field lines intersect each other? You know that the field lines actually the tangent at any point, say this is point P, the tangent at that point shows the direction of magnetic field. For one bar magnet, it will have one magnetic field. If they are going to cross each other, so say these are intersecting each other, so I have one direction at this and one direction this. So one magnetic field, say on a plane of the board here, so magnetic field will have only one direction. But when they are intersecting each other, at the point of intersection, I can show two directions of magnetic field, which is not possible. So that's why two magnetic field lines can never intersect each other. These are a few properties of magnetic field lines. So what all we have discussed today? What are magnets? What is the main difference between the permanent magnet and temporary magnet? Then we discuss about magnetic field, magnetic force, that it has both direction and magnitude as well. Then we discuss about magnetic field lines. Then we discuss about the properties of magnetic field lines. That's all for the day. Stay safe, stay healthy, and a very big thank you to you all. Bye-bye. Please subscribe, share, and like my channel if you like the content.